Hello students, welcome to the second year class of Computer Engineering and Information Technology. We are going to study the data structure using C. The subject code is 22317. Myself, Mrs. Premlata Bharambe, will going to continue your further syllabus for the data structure. Okay. Now we will see the today's learning outcomes for this video. In the previous videos, you have learned about the searching. We are at chapter 2, that is searching and sorting. So you know that the searching is the process of finding the element at the particular location. Means finding the location of that particular element. Now we will going to see what is sorting and sorting methods, categories of sorting, methods of sorting. In the methods of sorting, we will going to see bubble sort method. Firstly, we will see what is sorting. The sorting is the process of arranging data or records in a sequence is known as sorting. The process of arranging data numerically or alphabetically, either is ascending order or descending order. It is also known as sorting. And we are sort the data from the list, and the list is nothing but the collection of records which contains one or more records or one or more elements. The example of sorting is telephone directory and dictionary. As we know about the telephone directory, in the telephone directory stores the telephone number of the peoples sorted by their names so that the names can be searched easily. And the dictionary is the best example for sorting. In the dictionary, data is stored in a alphabetical order. Data means words. In the dictionary, words stored in the alphabetical order so that we can search that word or that particular word at any time, and we can search that easily. The techniques of sorting can be divided into two categories. First is internal sorting and second is external sorting. Firstly, we will see what is internal sorting. If all the data is to be stored can be accessed at a time in the main memory, the internal sorting method being performed. Then external sorting. When the data is to be sorted can be accommodated in the memory at the same time and some has to be kept in auxiliary memory such as hard disks, floppy disks, magnetic disks, that is external memory. Then external sorting method are performed. Then we will see efficiency of sorting techniques. Efficiency is used to analyze the algorithms. Means it is used to get the amount of time required to sort an array of n elements by a particular method. The normal approach is to analyze the method to find the number of comparisons or number of exchanges required by it. There are three types of efficiency. Means it is also called as cases of efficiency. First is our best case. It is measured in a minimum time that this algorithm will require for the input. Means to execute the algorithm, time to execute the algorithm is minimum. Then we can call this the algorithm is in best case efficiency. Now second is worst case. The worst case means the time for requiring algorithm execution will be more than average. Means it is measured in the maximum times. Then we can call that the algorithm is in worst case efficiency. Now third is our average case. The average case means it determines the average time complexity. Then we can call that the average case efficiency. Now we will see the different types of sorting. These are bubble sort, selection sort, insertion sort, radix sort, quick sort. These are the types of sorting which we will going to learn one by one. Now we will see what is bubble sort. The bubble sort technique is a simple algorithm which is used to sort given set of n elements provided in the form of an array with n number of elements. Bubble sort compares all the elements one by one and sort them based on their values. Sorting takes place by stepping through all the elements one by one and comparing it with the adjacent element and swapping them if required. Means in this technique we are comparing the adjacent element. If element first is greater than element second, then we can swap that element. Now we will see algorithm of bubble sort. First, given an array of n atoms, compare pair of adjacent atoms. Swap if the atoms are out of order. Repeat until the end of the array. The largest in the bubble sort, the largest atom will be at the last position, that is fourth position. Means if elements are if there are 5 elements, then the largest atom will be at the last position, that is A of fourth position. And then after that reduce n by 1 and go to the next step. Means large atom like a bubble that flows to the end of the array. This is the algorithm for bubble sort method. Now we will see the implementation of bubble sort. This is the implementation in C programming. Void bubble sort. This is a function. Bubble sort is a function name and this is the variable declaration in the parenthesis. Integer a square brackets integer n. Means in integer a, here we are declaring the array. For n for integer I is equal to n minus 1, I is greater than or equal to 1, I decrement in the first for loop. Now opening curly brace. For integer j is equal to 1, j is less than or equal to 1, j increment. Then again opening curly brace. Now here we are comparing the adjacent element. If the condition is true, then swap. If the condition will false, then no swapping. No, there will be no swapping. Means the elements remains as it is. These statements are compare the adjacent pairs of number, and this is the swapping statement. And first for loop closing, second for loop closing, and this is third for loop closing. Now we will see the example. This is our unsorted list: 14, 33, 27, 35 and 10. The array index for these numbers are A of 0, A of 1, A of 2, A of 3, A of 4. There are n number of elements, means there are 5 numbers of elements. So number of passes required for this bubble sort method is n minus 1, that is 4. We required 4 number of passes. Now we will see one by one. Now in pass 1, the bubble sort start with the very first two elements, comparing them to check which is greater number. First two numbers are 14 and 33. 14 is less than 33, means it is already sorted. So we have to compare next element. Next element is second element compared with third. And yes, we have to compare the elements 4 times. Means in pass 1 we have to compare n minus 1. In pass 2 we have total number of comparisons are n minus 2. And in pass 3 total number of comparisons are n minus 3. Like this we reduce the comparisons as we got the sorted elements. So we are in pass 1. So we have to comparison the 4 times. Means iteration process will be done 4 times. This is the first iteration. Now we will go for second iteration. In the second iteration, 33 and 27 number will be compared. Now in these two numbers, 33 is greater than 27. So the values must be swapped. Then our sorted list like this: 14, 33, 27, 35 and 10. This is our array. Now we will move on next two values, that is 35 and 10. In the 35 and 10, 10 is smaller than 35, hence they are not sorted. Now we are comparing 10 and 35. 10 is smaller than 35, so we are sorting them. We compared 33 and 35. We find that both numbers are already sorted positions. Okay. We swap these values. We find that we have reached at the end of the array. After one iteration, the array should be like this. Okay. This is after pass 1. Now we go for pass 2. In pass 2, to be precise, we have now showing how an array should look like after each iteration. After the second iteration, it should look like 14, 27, 10 and 33, 55. Means in pass 2, these two elements sorted. And in pass 2, the total number of comparisons are n minus 2, means 5 minus 2 is 3. Then in pass 3, total number of comparisons are n minus 3, means 5 minus 3. There are two total comparisons in the pass 3. Notice that after each iteration, at least one value moves at the end. Means at least one element is sorted. Now 14, 10, 27, 33 and 35. These are the three elements we will get sorted after pass 3. Now after pass 4, we will get the completely sorted array list, that is 10, 14, 27, 33, 35. And in pass 4, we had to compare only once time, because the total number of comparison is n minus 1, that is 5 minus n minus 4, that is 5 minus 4 is 1. So in pass 4 we have to compare at once only, and after this we will get this sorted list. Okay. Now we will see the second example for bubble sort method. This is the second example. There are the 5 total elements in this array. A of 0, A of 1, A of 2, A of 3, A of 4. These are the array index. And the 23, 15, 19, 11, 1. These are the elements. So we have total number of elements n is equal to 5. So number of passes we required n minus 1, that is 4. In 4 passes we can sorted this list. In the pass 1, this is the list for pass 1. Unsorted array list. This is for pass 1. First is 23, second element is 15, then 19, 11 and 1. These are the unsorted array. In pass 1, first compare element at A of 0, 23, with the element A of 1, that is 15, and as element 23 is greater than 15, so interchange them. Afterwards we will get this list: 15, 23, 19, 11 and 1. Then we will going to compare the next two elements, that is 23 and 19. At A of 1 is 23 and A of 2 is 19. As 23 is greater than 19, so interchange. Now next iteration: 15, 19, 23, 11 and 1. Now we are going to compare the 23 and 11. As 23 is greater than 11, so interchange. Now next, in the next iteration, we got this sorted list: 15, 19, 11, 1 and 23. In pass 1, we got this sorted element, that is 23. Now we will go for pass 2. In pass 2, number of comparison required n minus 2, that is 3 comparison should be required for this pass 2. Now the elements are, after pass 1 we will get this list: 15, 19, 11, 1, and already 23 is sorted. Now we will going to compare the first two elements, 15 and 19. As 15 is less than 19, so don't interchange the elements. Then in the next iteration, 19 and 11 will be compared. 19 is greater than 11, so interchange the elements. In the next iteration, 19 and 1. 19 is greater than 1, so interchange. So after the iterations of pass 2, we will get this sorted list: 15, 11, 1, 19 and 23. 19 and 23 are the sorted elements after the pass 2. Now we will pass 3. In the pass 3, our list is 15, 11, 1 and 19 and 23. These are the already sorted elements. So we have to consider these three elements. In the pass 3, total number of comparison required n minus 3, that is 5 minus 3. It means we have to require 2 comparisons. So firstly we compared 15 and 11. As 15 is greater than 11, so interchange that elements. In the next iteration, 11, 15, 1. 15 is greater than 1, again interchange the element. After this pass 3, we will get the third sorted element, means 11, 1 and 15, 19, 23. This is the 15, 19, 23. These are the sorted elements after pass 3. Now next is our pass 4. In the pass 4, total number of comparison required n minus 4, means only one comparison is required. 11 and 1. These two elements are unsorted. That's why we are going to compare these two elements. As 11 is greater than 1, so interchange the elements. The final sorted list after pass 4 is 1, 11, 15, 19 and 23. In this way, we got our In this way, we got our sorted list using bubble sort method. This is 1, 11, 15 and 19 and 23. Now we will see the C implementation of bubble sort algorithm. We have to write the program in the C. This is the window of C programming. Here, program to sort an array using bubble sort method. These are the header files. Hash include stdio.h, hash include conio.h, hash include math.h. We included math.h because we have to calculate some functions, some mathematical functions. That's why we have to include that math.h header file. Then this is our main program, void main, opening curly brace, variable declaration. In variable declaration, we have declared array of 100, n, I, t, j and pass. These are the variable. Then clear screen. Then we have to print the enter the size of array. Scanf means take the values from user. Printf again, enter the elements in the array. And this is the for loop for input of array. For I is equal to 0, I is less than n, I increment. This is for the input of array elements. This is the condition I is less than n. This n means this n. If we have to enter the number of element 5, then it will take only 5 elements. Yes, it is the user through value in the array. Scanf %d ampersand a of I. Now next is our bubble sort implementation. For pass is equal to 0, pass is less than n minus 1, pass increment. Opening brace. For j is equal to 0, j is less than n minus 1, j increment. Close opening brace again. Now here we have to compare the two adjacent elements. If a of j is greater than a of j plus 1, then it will swap. This is the swapping techniques. This is the swapping technique or swapping logic. T is equal to a of j is equal to a of j plus 1, a of j plus 1 is equal to t, and this is the first for closing, this is the if loop closing, for loop closing, second for loop closing and first for loop closing. These are the closing curly brace. Now finally this printf is the sorted element. This is used for to print the sorted element, and this for loop is used for to print the sorted element list in the array. For I is equal to 0, I is less than n, I plus plus. Then printf %d a of I. Means we have to remember that if we are taking from user, then in scanf we are writing here ampersand a of I. But we have to print the sorted list. That's why we take here the printf statement, and in the printf statement we have to write the data type specifier as a of I. This is called as the data type specifier. Okay. Then we will see the output of this program. The output of this program is here I entered the size of array is 4, and these are the elements, that is 76, 23, 56, 21. And after the bubble sorting methods, the list will be sorted, and the final sorted list is printed here. That is 21, 23, 56 and 76. These are the sorted elements using bubble sort method. Okay. In this way, we have learned about the bubble sort method. in the sorting techniques. Means we have learned the sorting method means arranging the elements in the alphabetical manner or in the numeric manner. Now we will see some MCQs, but before that, the bubble sort works by starting from the first element and swapping the element if required in each iteration. This is the concept of the bubble sort. Now the first MCQ is, what is an external sorting algorithm? Algorithm that uses tape or disks during the sort, algorithm that uses main memory during the sort, algorithm that involves swapping, algorithm that are considered in place. The answer of this question is algorithm that uses tape or disks during the sort. Now the second question is, what is the worst case complexity of the bubble sort algorithm? These are the options: big O notation n log n, big O notation n log n, big O notation log n, big O notation n, big O notation n square. And the answer is D, big O notation n square. Now next MCQ is, what is the advantages of bubble sort over other sorting techniques? It is faster, it is consume less memory, detects whether the input is already sorted, all are mentioned, and the answer is detects whether the input is already sorted. So we have seen that if the elements are already sorted, then we need not we no need to sorted them again. In this way, we have learned about the bubble sort technique. Thank you.